All right, good morning and happy Saturday. I'm planning on doing LeetCode contest 311 from last Saturday, so I'll do this virtually. I'll plan on doing it in Python and yeah, I'll do all the languages that I know, and I'll struggle with Rust. Okay, so here we go. All right, open these guys up. Smallest positive integer is a multiple of 2 and n. So if in, let's see, let's just do this. 2 in modulus 2, turn in, otherwise return 2 times n. It's probably okay. All right. AB is the longest continuous substring. Yeah, so we can just use the sliding window, right? Nothing too fancy. And is the length of S, I, and J are 0 and 0, from which we'll expand the sliding window while J is less than N. And then best will be the longest length that we got. All right, so return best at the end. Okay, so we're starting at I equals J at the end. And then let's do for K and range I. Wonder if we need J in this case, right? At each starting position, we'll run as far as we can. Call this thing J. J equals I, all J is less than N, I plus 1. Well, actually, J plus 1 is less than N. And ordinal value, let's do this. Ordinal value of S sub J plus 1 equals the ordinal value S of J plus 1. Then J plus equals 1. So move it forward to I to J inclusive. So best equals maximum best. J minus I plus 1 for I to J inclusive. Right, plus 1 for I, J inclusive. Then I equals J plus 1 at the end there. Okay, so I think that works. Let's see what happens. 2 and 5. Uh-oh, too many values to unpack. Oh, that's right. Got rid of J up here. Start at I, go to J. Yay. Reverse odd levels of binary tree. Every other level switched. Okay, fine. Just do a Q, BFS. I think, great. It's perfect. They all exist. Every other level, right? And look at this one. Make sure I understand it. A lot of times I'll end up solving the problem that I'm not supposed to be. So these are swapped, and these are swapped. So just read them in K levels at a time. right? Using Q, BFS. Let's see. So Q is her deck root. All Q. K is the length of the current Q, and then let's keep track of depth as well. Depth. If depth is odd, then we'll reverse the next portion of the Q. Current kth row. Let's call it row, is fine, right? Row equals row inverse. Oops. Wait, how do we reverse the row? Reverse the row from its. Oh, it's a little bit more complicated than that, right? Because we need to change the pointers of the parents. So keep track of the last row and the current row. Previous and current. Okay, so pre-current rows. Previous row and the current row. All the previous row will go around to kth current row. Or actually, I wonder, does it make sense to change it? I mean, we could serialize and deserialize it too. That would work, right? Serialize it into an array and deserialize it. Whatever. I'll just do this for now. For each node in previous, append node.left, append node.right. Previous equals current at the end here, and then we'll return the same root at the end. Our node in previous, current append the left, then the right. Then if it's odd, we'll reverse current and update previous pointers to current for node in previous and reverse. This be a deck so I can pop left. Node dot left equals cur dot pop left. Node dot right equals cur dot pop. I guess we can pop it in reverse, right? So current will be previous, can be, yeah, make it simple, right? So pop from the right and push it to the left, right? Okay, that makes sense, I think. All right, something like that then. Let's see what happens. Use example test cases. Set, no object left. Oh, hold on. So if current is Wait, hold on. Yeah, when does it end? All right, there's no left and right. If node dot left, if node dot right, if not length of current, then we'll break all true. Oh, no, oops, node. Does that look right? No. 2538, no, that's not right. So this should be backwards, right? Do that thing backwards. No? What? Depth? Oh, I'm not incrementing depth, right? Depth plus equals 1. I think that works, right? You go to the left and you go to the right. No? Wait a sec. $34. Whoa, this is like way off. Oh yeah, so I don't want that. I want this, right? So update previous to the current. Okay, that looks right. 7, 11, 13. Yeah, okay, cool. And then 0, 2, 1, 0, 0, 0, 2, 2, 2, 1, 1. Okay, that's good. Oh, oh no. Oh, when I update these planners, I'm updating these ones inadvertently. Oops. Okay, so if this, then that. Otherwise, we do have to update it the other way, don't we? Wait, I think we always do this. Does that look right? No, I don't think so. 253, 2134, 813. That should be 813, 2134. Like this should not change. This portion should not change. But that portion should. 2 to the 14th, the number of nodes, it's huge. Wait, no, that's not that big, is it? 2 to the 10th is, okay, so it's only a few thousand. Let's just do this. Make life easier on ourselves. Remember, KSS equals keep it super simple. Let's just serialize and deserialize it, right? Here's my array. And then every other one, just do pre-order traversal. Right, so a dot append node dot value, go node dot left, go node right, go. Or let's see, so if I equals 0, and while I is less than length of A. Create a tree. The answer, right? Can be root, the root value, right? Tree node, a sub 0. Return the answer at the end. I shifted left by 1 for the next power. Go from I to J. How about show? This is the next power of 2. So F is incremented by 1, and then we'll just reverse this thing. If depth is odd, row equals row and reverse. I'm gonna call this thing called go to get those stuff. And just call this thing do is fine. Do. Yeah, that should work. Return do. I 0. Wait, I just want to, what do I want to do? I want to go through and create the tree from the array. Create new, I guess, when do I want to create a new tree node? How do I want to do this? I think it makes sense, yeah, to just do this. Keep it super simple, right? Tree node a sub 0. Turn the answer at the end. So keep track of the previous row and the current row. So previous equals answer, current based upon previous. Hold on. TI and the depth. current is reversed. Do a tree node like that. Or node, let's just call it U in previous. Or just call it node is fine, right? Just set it to the current. Do you want to pop left or pop right? I suppose. Hold on, I think I'm making this way more complicated than it needs to be, right? So I want to serializes the node, right? And the tree, that's fine. When I deserialize it though, yeah, I can do it recursively, right? Do I want to do it recursively? No, because I want to do it in reverse without adversely affecting the other stuff. Right, every other one swaps every other one. Yeah, I think we do want to always swap then. Previous is an array of that. Pop that guy. Pop that guy. Take will be a copy of current. Previous rows, left and right are filled with the current ones that we take. And those are copied by reference. And then previous equals current. Something like that. Oh, you don't append. You don't append. Oh, if not node, just return pop from empty list. Uh-oh. I is less than I shifted left by 1. Is that right? Yeah, because we don't want to go to the very last row. Uh-oh. Okay, now I'm just making a mess of the things. What am I doing? Like, okay, so when we swap these, we're not affecting these though. We don't want to affect those. Which means we do have to modify the entire tree. Right, so this seems like a decent idea, right? So let's do this. Print A. Oops. And there's my array of stuff, right? The pre-order traversal, this stuff. And then wait a sec. Oh, I don't want pre-order traversal then, right? Do I in-order traversal? No. Hold on, I thought left and right child. Oh, okay. So that doesn't really help me much, right? Left and right child are two times I plus one. Okay, let's rethink this. Fast is slow and slow is fast. So if we reverse this one, and that means we reverse this one, we need to reverse that one for it to be back in the usual order. So we're always reversing everything, right? Keep it super simple. Always reverse everything. Go through it, acquire it, then reverse it. Go through it, acquire it, and then reverse it, right? So here's the game plan, right? Let's do this. Game plan, reverse each row, right? Based upon previous row and current rows, right? Just keep it super simple. Previous equals the root. I'll turn the root at the end. Current is this thing. Our node in previous, node dot left equals cur dot pop. Previous needs to equal current, right? Previous to equal current. This guy's previous, this guy's current. Current is swapped, and then previous needs to be this guy next. All right, so take is a copy of current. Take the pop. Pop in reverse order of what you got, Dan, right? Previous equals current. Current is this thing, and then if not length of current, break for node in previous cur dot and node value, or no, just the node, right? The node dot left, node dot right. Cur dot append nodes right, left and the right of them. So here's previous, just to the left and the right and current, and then pop them in first. Sit them there as we take them. Does that work? No attribute left. Previous current. Let's just do one. Really? It's not working? None type object, there's no attribute left. previous, current. If no dot left break 253. These two are backwards though. This one's supposed to be backwards, but this one's not. Right, this one should be unchanged. $13.8. So those are still backwards then. Yeah, this isn't quite right. So the first time is right though. The 5 and the 3 are correct. 13 and 8 are backwards though. And 34 and 21 are backwards too. Oops. It's a little tricky. See how much time we have left in the contest. We still got an hour, so it's cool. Remember, right? Fast is slow and slow is fast. People. And I am a part of people. Be kind to myself. Like some of these things are hard to do online in an editor. I think it'd be way easier if I actually draw this on a piece of paper, right? Rather than just kind of like do it all in my head. Let's do this. Let's print out print previous, print current. Right, for each iteration, we have two. This is really ugly. Add that file for node in on a separated list. Whoa. Okay. Let's do some debugging. So 2, 3, 5. 3, 5, 8, 13, 21, 34, right? So these are our previous and current rows. When I swap these two, it's going to swap these two as well, right? So I need to rewrite those. Okay, yeah, so the order I rewrite those in does matter. Right, okay, so if based on the depth, depth 0, depth is incremented. So if depth is odd, when we swap these two, 21 and 34 over here, or should I just update the values? Oh yeah, I should update the values, not the nodes themselves, right? Yeah, if I update the values, then the pointers don't change. Okay, that makes it way easier. Okay, here's a key point, right? Oh yeah, duh moment. Update the values of the nodes, not the nodes themselves, right? That makes life way easier on myself. Right, okay, so previous is this guy. So if not node dot left break, fine. Node dot left dot val, node dot right dot val. Current doesn't exist, fine. Okay, so let's do this. So if not pre sub zero dot val break, right? So while left, right? While there's a next current row. Wait, okay, so I do need to update the values and keep track of the nodes. Without updating the pointers. Okay, I do want to grab the nodes themselves and then update their values. Listing values. Node.val for node in current. Vals equals vals in reverse. For node in current. Pop them in reverse, right? Node.val equal vals.pop. Right, if it's odd depth, we take every node in the current and just update the value, not the pointers. Previous equals current. Okay, that looks good. No, not a local variable node reference before assignment. Or node in previous. Okay, so this one is reversed. 34, 21. Okay, so oh man, I can make this way easier, right? Okay, that is easier to just update the values of the existing nodes without updating the nodes themselves. All right, let's do this. I think this is a working solution. Okay, I think that looks good. Yay, okay. So here's the major point. Don't update the pointers themselves, just update the values and keep the structure intact. And then I can definitely clean this up quite a bit. Okay, so let's just do it each row at a time. Well, the length of the row. And we don't need to update current based on previous because we're not actually changing the pointers. We're just changing the values of the current row. All right, so let's update this, right? Gotta keep track of that. So if that is on, then we'll update the row's values. Take these values, right? And node.5 for node and row. And for node and row, node.value equals take.pop. All right, so basically reverse that row's values. And we do need to keep track of the next row too, though. Okay, so it does make sense to have a previous and current row then, right? Right, does it? Or can I just do this one row at a time? I'll just simplify this. This is our Q. K equals the length of Q. Okay. Let me process that portion of the Q to create the current row, current kth row. Current equals Q dot pop. Row dot append, row dot left, row dot append, current, I'll just call this again node. How about node. Okay, so that's our row, our kth row. Yeah, I don't think this is too shabby of a solution actually. We can clean this up. I don't know, that's kind of ugly. I'll grab some more coffee and then refactor this. All right. Yeah, this isn't too bad of a solution. It's not too shabby. Current values are updated in current. Previous has a left, right? So we don't need that part. It looks okay. It's pretty decent, right? Previous row, build the current row. We don't need that either. Right, yeah. It's a decent solution. I do it in reverse. Don't need depth maybe. Let's just do this. Odd. If odd, odd is flipped. Oh, I don't think that's right, is it? No. If odd. Odd initially is one. Oh, that's good. Values. Oh, you know what? I can actually change this up a little bit. All right, we can do if odd here. Something like that, right? Yeah. For I in range, length of current. Current ith node value equals n equals length of current. Usually we reverse them, right? Current n minus 1 minus I. Just do half of them in reverse rather than using the ephemeral data structure. Ith value equals the last one's value, right? We basically swap them. N minus 1 minus I val. So n minus 1 minus I val recursive on dot val, right? That looks good, I think. 7, 11, 13. Yeah, that's good. So then we don't need to have this vowels, right? We just swap them. Yeah, that's a decent solution. That's cool. Okay, so we have 40 minutes left. About 40 minutes remaining in the contest. Okay. A, B, Answer for each string is as follows. ABC has 3 prefixes. Itself What? A, B, and ABC. There are 2 strings with the prefix A. 2 strings with the prefix AB. And 1 string with the prefix ABC. AB has 2 prefixes, A and AB. BC has 2 prefixes, B and BC. There are 2 strings with the prefix B, 1 string with the prefix BC. Thousand, and each is 1,000. Thousand times 1,000 is a million. Each of those. Yeah, so this does seem to be dynamic programming, right? I think so. EP using past to formulate future. I think what's been previously seen and how many times? In buckets. Go through each one at a time. No. Okay, so yeah, what's the game plan then, right? What's the game plan then? For each prefix, let's see what other prefixes there are. Length 1, A. There's 2. You see, I may just brute force and optimize. Brute force, working the solution, then optimize. All right, TLE solution. All right, so if I was going to brute force this thing, basically for each word, for each prefix of each word, find out how many of the prefixes there are. There are 2 strings of prefix A. How many other strings start with that? How many other strings start with A? How many other strings start with AB? How many other strings start with ABC? Which are array of words? Score is 0 initially. We'll turn the score in the end. For each string in the array of strings. Or k in range length of the string. 0 to k inclusive. Our target is s sub to k inclusive. Or non-inclusive, right? +1 for 0 to k non-inclusive. Target count equals the length of the filtered string A where the prefix equals that. S and A. One for S and A if S sub, let's do this. No, but it had that final value as score plus equals that, right? Okay, that should be brute force. Nope. Uh-oh. Integer. Oh, it needs to be okay. Answer is an array. And append the count. Count is 0. Count is incremented by the sum of the same prefix. Cur is not defined. Oops. And the count. Turn the answer at the end. 5, 4, 3, 2, right? And then the other one's 4. Oops. Uh-oh. Oops. Answer needs to be down here. Just pass by reference in between test cases. Okay. So that's brute force TLE that we can optimize. Is a good starting point. Should TLE. Okay, so that's expected. So now how to optimize, right? Question. Optimize this. Thousand words, each of length 1,000. Can I keep track of every single thing in a bucket? I don't think so. How would you build something upon something else? Let's see, we have about 30 minutes left. So there's time. Get that Q4, that unicorn. X. It seems that we could create buckets, isn't it? But then that would TLE too. We have a bucket of A bucket of AB, or count of. That's basically what I'm doing. All right, I'm making the count of each. Maybe go through them column wise. The first character built upon the previous one. 1A, 2A's, 1B, 2B's. Process the input in a way that makes sense. Does that make sense? Reprocess the input, like sorting for greedy consumption. Sort lexicographically. String size. Then lexicographically. So strings of size 1. Lexicographically of size this guy. So this guy would basically turn into B, AB, BC, ABC. Gotta go pee real quick. I'll be right back. Okie dokie. Why is this? Music going, okay. Um, or just sort lexicographically. A, B, A, B, C, B, B, C. Well, I can't sort it actually because I need to, that's actually, hold up. All right, we can't sort because the original list matters, right, for the count of each element in that list. Score. Okay, so sorting was a decent idea, but I don't think it's going to work out here. It's not going to help us out. So how can I use the past to formulate the future? That might be a better question. Right, brute force just kind of repeats things over and over again. Right, we look at A, look at AB, hit B. Hmm. I just use a map for each substring so we don't have to look them up. I wonder if that would TLE or not. What if we use a map, right? What if we process each string's substrings and use a map? Store counts. I suppose it's a step forward, right? Registering A for A in range the string plus one. The substring is S into K. Map can be a counter. And so that guy is incremented by one. Then we create the count for each of these things. And instead of doing this, into count plus equals this guy, the mapped value of that guy, right? Okay, something like that. Okay, and then see if this TLEs or not. Ooh, that looks good. Oh, nice. Okay, cool. Woohoo! Yeah, we got 19 minutes left. That's awesome. Okay, so time to go back and do these in the other languages and post them to the discussion boards. So if n is evenly divisible by 2, it's n, otherwise it's 2 to the n, right? So this is like kind of silly. And n if not modulus 2, if it, as long as it's not odd, right? It's 2 times n, right? And you can like that one. Uh-oh, is that right? 10 and 6? It is right, okay. Okay, cool. Let's do this. View solutions. There are two cases to consider. Case one, if n is even, then return n. Two, if n is odd, then return 2 times n. Okay. Plan script. Oops. 3 plus C++ Python. Turn if n is odd, 2 times n, otherwise just n. Good. It's cool. Okay, JavaScript. N is odd. Or let's do this. Shift it left by 1 and multiply it by 2. This will keep this guy consistent. Oh, actually, check this out. And let's just do this. And shifted left by n modulus 1, right? So you shift it nowhere or shift it somewhere. Yeah, that's cool. The best code we write is the code we don't write. Right? Keep it super simple. And shifted left by whether or not if it's odd. Oh, that's cool. Kind of convoluted, but whatever. And shifted left by has to be shift in left by 1 if and only if n is odd. That is a little bit weird when it comes to this. Shifting left. Let's see. In shift left, I in and one. Okay. Save the best for last for Rust. Should be okay like that, I think. It's cool. All right, let's post this. What are this folks have to say about this? Good solution. Yep, same thing. Works. Okay, cool. Alrighty, so this one is the sliding window from I to J. Right, so pretty straightforward. Longest continuous substring. Okay, this works, right? Do this in the other languages real quick and then copy and paste it in there. Hold on. G plus one is less than n. Yeah, that works, right? It's cool. Decent enough solution. Plus one for I to J inclusive, right? So sliding window of I to J inclusive. Is a sliding window I to J inclusive. And JavaScript, Python 3, Rust, C++, boom, bam, bam. Let's do this. Here. Best at the end. Oops. As less than n. J is I plus one. Let's do this. J plus one is an n, and a sub j plus one equals a sub j plus one, or s string. J plus one at the end here. And j, and then best is the maximum best, j minus I plus one. Oops. This one for ij inclusive. Looks good. 295 is cool. this in here. JavaScript. in equals 0. Length of the string. Oops. The best of the end here. Ordinal value. See the char code at 0. Ordinal value of S of j plus 1 is equal to ordinal value S of j plus 1. J. Best equals the maximum itself and j minus I plus 1. Plus 1 for I to j inclusive. Equals j plus 1. Okay. That's cool. Okay, Python. Character code. I just do 2int. I said j dot 2int plus 1 was S of j plus 1 dot 2int. S equals the maximum itself, j minus 5 plus 1. It's 1 for I to j inclusive. It's good. It's cool. Okay, and then rest. Save the best for last here. Soup. Leave best. Return best at the end. I equals 0. The string. While is this the end? J equal I. J plus 1 is less than n, and S of j is u8 plus 1 is equal to S of j plus 1 is u8. Increment j. Last equals use comparison to maximum. Maximum itself, j minus I plus 1. Plus 1 for I to j inclusive. And then I equals j plus 1. Okay. Uh-oh. I'm gonna index a U size. At s equals s dot chars dot collect as a vector of characters. Uh-oh. Best, okay. Side 32. Yay, looks good. Looks good. Let's move on. We have 4 minutes left in the contest. Looking pretty good. All right, that's cool. All right. And this one. So this one really threw me off when I was switching around the pointers, the left and the right. So just switch the values, keep it super simple. Solutions. All right, just all right, build the current row based on the previous row, right? Perform BFS for, I guess, yeah, it's just traverse the trees rows using the previous row. Do I need previous and current? I don't know. Yeah, because each row itself. Yeah, do I need previous and current? I don't think so, actually. No, yeah, I do need previous, right? Because I do create current based on previous. It is a pretty decent solution, right? Using the previous row to acquire the current row. Note, it is much easier to manipulate the node's values rather than the node children. We can simply reverse each odd row's values rather than modifying the left and right odd pointers. All right, so I got a little bit in the weeds because of that, using myself. Good learning experience. Keep it super simple. Okay, so this guy. I guess we don't need that. It's a different value either, right? I think the current can be here. In is not, oh, I do use in, okay. No, because in is, yeah, from the back side, okay. Yeah, so it's cool. Just leave it like that, that's good. Not to be perfect. That's good enough. That is cool. Okay, let's do this in the M languages. Let's see. Hold on. Vector is equals vector of planners. Is previous is root. Well, previous of 0, left child, and root at the end. This one odd. We flipped on and off. If odd, and we'll swap values to reverse the current row. Nodes current for node and previous. Current dot push back. Node dot left. Oops. Back. Right. Let's do this. Oops. Looks good. Okay, cool. Okay, push those guys there. And then if on swap those values. Previous was current, odd is a flipped bit. At length and 4, 0, 1 is less than 1 over 2. recursive I, recursive n minus 1 minus r, recursive n minus 1 minus I, val. Basically just swap these guys to reverse the odd rows. Looks good. It's cool. All right, do Kotlin. Right to the end here. Our pretty equals equal list of three node. The rest of goes extra one. Previous goes current or node in the previous. Add node node left val node right odd, and we'll reverse the currents. Okay, basically just swap these guys. Well, tree nodes expected. Looks good. It's cool. All right, there we go. Traverse the tree's rows using the previous row to formulate the current row. It's much easier to manipulate the node's values. Mm-hmm. It's good. So the previous row to formulate the current row. Okay, cool. And this one, I'm just using a map basically to store all the prefixes of all the strings, right? Nothing too fancy. This is actually a pretty easy Q4 in that I didn't need to use DP, right? I was thinking I had to use DP, but that would have been overkill. All right. View solutions, use a map to store the count of each string S, each prefix string of each string S of the input array A. Mm-hmm. And JavaScript, oops, on 3, Rust, C++. Okay, so we got Python 3 here. This looks good, right? Coming by one. Yeah, that looks good. It's a good solution. Right? That's cool. Count. Users count them. Uh-oh. Doesn't look right. Oh, it's 0 until K. 0 to K non-inclusive, not K onwards. Okay, that's cool. Oh, all right. Well, C++ is slow. Maybe I got lucky in Python. Let's see. JavaScript, usually the OJ, the online judge is a little more lenient as well. Input array of words. Let's do this. Yeah. Nah, it's all right. Whatever. Set this guy 1 plus. Get that guy over nothing. That guy. Okay. Oh, what? Two's not about value. Oh, oops. Push the count onto the answer. That's not right. 0. Subster. Nope. Subster. Let's do this. Log my map. What's going on? 1A. Oh, wait, plus equals. Get this guy or 0. Okay. Uh-oh. Set the substring. Get the substring or 0. Want to add it onto that. Okay, that looks good. Woo. Alrighty. Huh. Well, TLA too. Okay, maybe I got super lucky. All right, good enough.